So this is question number 53 of GATE 2010, which is a common answer question. So the common question is that consider the propagation of the electromagnetic waves in a linear, homogeneous and isotropic medium with electric permittivity epsilon and magnetic permeability mu. So this is the main question which is given, and the first question is based on the relationship between K, E and H, and in fact for question 52 the option D is correct. But we will be focusing on question number 53, which states that if epsilon and mu assume negative values in certain frequency range, then the directions of propagation vector K and the Poynting vector S in that frequency range where these epsilon and mu are taking negative values are related as. So there are several options which are there. We need to see that which option is correct. Fine, let's go to the solution. So this is the solution. It is given in the question that epsilon and mu are taking some negative values in certain frequency range, and we need to establish a relationship between K and S in that frequency range where epsilon and mu are taking some negative values. That is what the question asks. We know that this S which we are talking about, this is nothing but the Poynting vector. So Poynting vector is defined as this is defined as E cross H or E cross B by mu naught, whatever way. So this is the general expression for the Poynting vector, E cross H. Now we already know that B is equal to K cross E by omega, or you can write it as K cross E by Kc. This is how the B is written, and B is nothing but mu into H. So H can be written as K cross E by mu omega. So this B, which was written earlier as K cross E by omega, now if B is equal to mu into H, then it will be K cross E by omega. So H will be nothing but K cross E by mu into omega. So this is what we have got here. Now S, as per the definition, it is E cross H. We are putting this H over here. So that is K cross E by mu omega. Now if we solve this triple product, then 1 upon mu omega is a constant which I have taken out, and in the bracket we have done this vector triple product E cross K cross E. All three are vectors. So it's a vector triple product or cross product. So the rule is that K E dot E minus K dot E into E. So this is what, if you expand this vector triple product, it will come out like this. Now we know that in the electromagnetic wave propagation, the wave propagation is always in a direction perpendicular to both electric field as well as magnetic field. So E cross B results into the wave propagation. Therefore K dot E, in between K and E there is a 90 degree. So K dot E will be 0 because it's a dot product. Dot product means cos theta will come between K and E. So theta is 90 here. So K dot E will be 0. So this is gone. Therefore what we left behind is that E dot E, which is mod E square or E square. Simple, the magnitude of E whole square. So it is K mod E square. So S comes out to be 1 upon mu omega E square. Now this K vector can be written as the magnitude of the propagation into K cap, the direction of the propagation vector, the unit vector. So K cap we have written. Now if mu is less than 0, which is given in the question for certain frequency range, then I have just multiplied with a minus because now mu is negative to make it positive. So S will be equal to minus K upon mu omega E square K cap. What we are seeing is that this Poynting vector and the propagation vector are negatively related, or they are anti-parallel to each other. This is what the key thing which we have got when we have established a relationship between the Poynting vector and the propagation vector. When mu is less than 0, we have found out that K cap and S are anti-parallel to each other in the same direction but in the opposite sense. So B will be the correct option for this particular question. So let's come to the question again. So K and S are parallel, which is incorrect. K and S are anti-parallel, which we have seen to be correct. K and S are perpendicular to each other? No, nothing of that sort is seen. And K and S make an angle that depends on mod epsilon and mod mu. No, that is also not seen. So K and S are anti-parallel is the only relation which we have established when epsilon and mu are taking some negative values. This is the relationship between S and K when mu or epsilon takes some negative values in certain frequency range. That is, the propagation vector and the pointing vector are anti-parallel to each other. So option B is correct for this question. Thank you.